So the system attribute domain is the area impacted or affected by something. In system safety, this attribute is crucial so that the system is adequately limited in size and scope so the analysis does not inadvertently become overly cumbersome. It sets up boundaries, complexity, and criticality to limit the safety analysis. It is easy to understand that the more complex a system, the more hazardous it can be. However, as we get into the more technical engineering analysis principles, it becomes crucial to understand the interrelationship between complex and critical, or how the criticality of the system, subsystem, unit, assembly, component, or part impacts the overall system's complexity. Criticality is the level of consequence on the system if a failure at any level were to occur. It's the level of consequence. How bad is it going to be? Single point failures are highly critical. Redundancy can be designed in to reduce the component's criticality. How critical can minor things be? Earlier we looked at an example of a faulty circuit on a metro train that caused this. And we looked at a cracked wing root on an aircraft that caused this. Both significant tragedies and loss of lives. These were parts, the lowest level of hierarchy, with high criticality and no redundancy, that resulted in catastrophe when they failed. The next system attribute, operations, can simply be divided into two sub-elements, functional and non-functional. Functional, what the system must do. Non-functional, how well must the system do what it's designed to do. How well does the firearm shoot bullets? Is it reliable? That's non-functional. Will the gun shoot every time the trigger is pulled? And will it not shoot when the trigger is not pulled? Both are equally important. In fact, your PowerPoint gives several failure modes. These are some failure modes that we will revisit later on in our lessons. But for our case, in our firearm, does it shoot bullets when we pull the trigger? Does it fail to operate if we pull the trigger? Or, equally as hazardous, if not more so, does it shoot when it's not supposed to, operating at the wrong time? Those are just two examples of some of the many failure modes that we can analyze in the operations system attribute in order to better know our system. And again, we'll revisit these modes later on in the course. There are many different types of systems. Knowing the system you intend to analyze can help you understand the level of complexity and thus the level of system hazard. Examples are given in your presentation with regard to static systems, dynamic systems, homeostatic systems, and cybernetic systems. Be sure to click on the link in your presentation under cybernetics for a phenomenal short video that quickly and concisely explains cybernetics. And this wraps up our presentations on system attributes. And next we're going to start talking about system safety.